Hey guys, so I noticed on the final exam a lot of you guys are having issues with this problem right here, and albeit it is very tricky, you guys still had the right setup, and it was just a matter of computation and execution that seemed to trip everyone up. So I'm going to go over this problem just because next term it's going to come up a lot more often with harder examples. So we'd want to make sure we get down how to do it now rather than later. So let's see. Let R be the region that lies inside of R equals 6, but outside of R equals 4 minus 4 sine of theta. Set up, but do not evaluate, and that is an important part, do not evaluate an integral or integrals to find the area of R. So right off the bat, let's look. We have two shapes here, and I'm just going to redraw them, right? We have our circle shape, and then we have what looks to be almost a circle, right? So let's do a U down here, but it comes up to this point, right? This indented point. Take note of that for later. So we have our two equations, and let's attribute them. This first one, R equals 6, is definitely going to go with the circle. R equals 4 minus 4 sine of theta is definitely going to go with this odd shape. So R equals 6, the radius is 6 of the first one, right? So we can use our equation, pi r squared, to find the area. And if we plug it into our calculators, we get pi 6 squared. That gives us approximately 113. The reason why we don't use a full decimal value is because a lot of the times when you're working with pointy shapes, it can kind of leak out the remaining decimal values, so we don't want to work with that. We just want to approximate, so we have a rough idea of where we're working, where we're headed towards. So now the second shape, right? We can't do pi r squared because this isn't a clean radius. It's not a clean circle. If you took the radius here, it would not be the same as here. That just doesn't work. But they do provide us with an equation, so let's see what we can do with it. R equals 4 minus 4 sine of theta. So, off the bat, we cannot plug this into our pi r squared equation because, again, we do not know the value of theta. And the reason for that is it's representative of this indent right here. So if we plugged it in, we would have a missing value and we can't compute with that. What we can do, though, is simplify it for now. So right off the bat, 4 minus 4, we can take that out, right? We don't need this messy, pointless term. So now let's rewrite our whole equation as 0 sine of theta, right? We can't simplify any more than that, but let's focus on this theta for a bit. What is theta, right? Let's actually break down the components that make theta so we can try to get it in a numerical format so we can plug it into our original equation, pi r squared. Theta seems to consist in this problem of a circle and a line. The rules of 2 states, though, that we cannot have 2 things, rather we need 3 things. So if we go back to the top of the equation and read the question, we'll see that do not evaluate an integral or integrals. Let's just focus on the one integral part. We would do more, but there's only one odd equation or one odd shape in here, so that's why it's a singular integral. So just plug that bad boy in. We get 0 minus in, or integral. So let's rewrite this. R is equal to, and then in this case, it's 0 sine, and then theta is just 0 minus integral. We can combine these two zeros, so we get sine of 0 squared minus integral, right? So now we got that value. So where do we plug it in, though, right? How do we plug it in? We need to substitute that, right? Because we can't have an r. This goes in a little odd. So if you look, right, and you want to use this pi r squared equation, we need a circle. How can we make this a circle? Boom. Look at that. This is the value of P up here. P for widow's peak. We're going to use the widow's peak formula to calculate the area, right? So P is also equal to R in this case because it's an irregular shape. So we're going to just, once again, plug in this equation here, and this is not the final answer. Rather, we're going to plug this in for pi r squared, or pi p squared. So pi p, which is just sine of 0 squared minus integral, and then square that. So let's plug in with our calculators. We're going to do second caret for pi, and this is again on a TI-84 plus CE calculator if you guys want to follow along. Then in the parentheses, we have the sine of 0 squared minus, and there's no integral button built into the calculators, but what you can do is you can hit alpha and then ln. That lets you use the letter s, which is synonymous with integral. And then we just get our closing parentheses and then square that baby. So when we plug it in, we should get an area of approximately 113. Again, we're going to approximate. We're not going to use any exact values. So let's go to the original picture. We know that the area of the circle, pretend that this is just a circle, is 113. We know that the area of this shape using the widow's peak formula is 113. Using the Venn diagram equation, we can see that these two indeed overlap. So if they overlap, that means they touch, meaning they're equal. Let's look at the areas. Since the areas are exactly proportionate to that, 113 equals 113. And what do we notice? That is true. So if we go to the top, we have the question, let R be the region that lies inside R equals 6, but outside of R equals 4 minus 4 sine theta. Set up, but do not evaluate, meaning do not get a number of an integral or integrals to find the area of R. So the area of R, using the Venn diagram and widow's peak formulas, is true. Thanks, guys.